Hi everybody, I hope you've had a chance to try these problems. Let's do them together to make sure you know what you're doing. We're going to graph y equals f of x first, so we're going to graph y equals 2x minus 8. We'll just make a rough sketch, so let's get our axes on here. We know the y-intercept is negative 8, so there's the point 0, negative 8. We know the slope is 2, and so we go up 1 and over 2, and it's going to look something like that. We can find here the x-intercept is going to be 4, 0, because 2 times 4 is 8, minus 8 gives us 0. So there's part A done. To find the equation for the inverse, remember, any time that we do an inverse, we're just switching x and y around. So the inverse equation would be x equals 2y minus 8. And now if we want to write it as y equals, we have to do a little bit of solving. So it's the solving just like normal. We add 8 to both sides. We have x plus 8 equals 2y. We can divide both sides by 2, and we get x plus 8 divided by 2 equals y. If you want, you can distribute the division and get x divided by 2 plus 4 equals y, or x divided by 2 is the same as 1/2 x plus 4 equals y. I'm going to draw that on the same grid. The y-intercept is 4, so that's going to be up here at 0, 4. The slope is 1/2, so we go up 1 and over 2, so it's going to go something like this. And the point back here, half of negative 8 would be negative 4 plus 4 is 0, so that's the point negative 8, 0. And look at that, the ordered pairs have swapped. 4, 0 became 0, 4. 0, negative 8 became negative 8, 0. That's how we know we've done it. And we can also see that the graphs are symmetric across the line y equals x. If we want to be really fancy about functions, we can call this, let me get back to the orange, we can call this new function f inverse of x equals 1/2 x plus 4. That tells you that this function is the inverse of the original one. That negative 1 means f inverse. Okay, let's do another one. Here we go, same idea, right? G of x equals 3/2 x plus 4 plus 6. Now, this is also a line, but it's in a form we don't always see that often. This is point slope form, remember. And so the point here is going to be negative 4, 6. That's a point that we know is on the graph. Negative 4, 6 might be up here somewhere. And if we go up 3 and over 2, we're going to have something like this. And so that's the graph of that. The inverse, we again switch x and y. So instead of y equals 3/2 x plus 4 plus 6, it's x equals 3/2 of y plus 4 plus 6. And again, we just solve. Subtract 6 from both sides. So x minus 6 equals 3/2 of y plus 4. You could multiply all that out if you want, or I can just divide by 3/2. Remember, dividing by 3/2 is the same as multiplying by 2/3. So I got 2/3 x minus 6 equals y plus 4, and then I subtract 4 from both sides, and I've got 2/3 x minus 6 minus 4 equals y. And again, we can kind of see that the point 6, negative 4 is on the graph. So 6, negative 4 would be, 6, negative 4 would be down here somewhere. And a slope of 2/3 means up 2 and over 3. So it's going to be more like this. And again, you can see that the functions are reflected across the line y equals x. The point negative 4, 6 became 6, negative 4. So the x and y have reversed. And again, if we want to be really notation about picky about the notation, we would say g inverse of x equals 2/3 times x minus 6 minus 4. You could, of course, still simplify and put it into slope-intercept form or mx plus b form, but that's fine right there. I'll do the next two examples in the next video.